this episode, I want to look at a Fisher's exact test with contingency tables larger than 2 by 2. Lots of data in linguistics fits into contingency tables, and what we're generally interested in is how the counts in the tables are influenced by the independent variables. Chi-square is generally used to analyze contingency tables. The assumptions of chi-square that the data are count data. The cell contents are mutually exclusive, meaning we can't put the same object into two cells, and the numbers in each cell must be 5 or greater. What if you have this hypothetical data where there are fewer than 5 in a cell? Well, Fisher's exact test is the way to handle it. It allows for small numbers in cells, and most stats packages include a Fisher's in a 2 by 2 table. But what if your data entail a much larger table? My research question was whether Portuguese speakers from different states use a different diminutive suffix depending on the final phone and stress of the noun that they attach to. Well, there are 26 states in Brazil, and that entails a large contingency table. Let's look at words with antepenult stress that end in E. Here's what the contingency table for the E final words being considered looks like. You'll notice there are lots of cells with fewer than 5 members. Chi-square just won't do. It's a 2 by 26 table, and it's going to be hard to find a stats app that will do a Fisher's on a table that big. But Jamovi can do it. Here's the raw data in Jamovi. Now there's no need to calculate the counts, just indicate what columns the data are in. Choose frequencies, independent samples, and we're interested in the influence of state of origin and the use of the xenu suffix. And we choose a Fisher's exact test. And you'll notice that the chi-square results are given even though the assumptions are violated. You'll also notice there are no results for a Fisher's test because we need to do something else in order to run a larger than 2 by 2 Fisher's. Jamovi needs to get under the hood to R to calculate Fisher's of large tables. So click in the modules in the top right hand corner, choose Jamovi library, scroll to find RJ editor to run R code inside Jamovi, and install it. Now we need to find the exact column names, in this case state_origin and xenu. Click on the circled R icon and choose RJ editor. And now we need to write some code into the editor. Here's what we need to do to run a Fisher's test. Notice state origin and xenu as the variables that we're looking at. So type that into the RJ editor. To run, press Ctrl-Shift-Enter or click on the green arrow. And what we find is the p-value of 0.3. Hardly anyone used any suffix other than xenu, and the distribution just doesn't differ by state. Now it is possible to analyze data with more variables. For example, we could look at the effect of state origin and gender on the choice of the diminutive suffix, and this would be the code for doing that. So to finish, large contingency tables can be evaluated with Fisher's exact test in Jamovi.